guys, so section 1.2 is all about understanding segments and angles. First thing we're going to talk about here is length. So the length of AB, of segment AB, which is also written as just capital letter A, capital letter B without the line, that is the distance between A and B. And I feel like that's something you guys probably already know. The only thing there is really the notation. So the length of segment AB, that's how we read this part, which is just written as AB without a line above it. So anything written like that just means length. All right. The word between, which is again, I think something you guys are probably pretty familiar with. But in order for a point B to be between 2 points A and C, all 3 points must be on the same line. All right, that's also called collinear points. So A, B, and C must be collinear. And AB, the length of AB, plus the length of BC must equal the length of AC. So for example, if we draw in A, B, and C, and let's say AB is 10, BC is 5, then we know that the length of AC has to be the two of those together. Okay, that's 15. So those lengths have to, length of AB plus the length of BC has to equal the length of AC, the whole thing. And that actually brings us to the segment addition postulate. So if B is between A and C, then the length of AB plus the length of BC has to equal AC. So it's again kind of the same thing, but we're going to be looking a lot at this as part plus part equals whole. All right. Then we're also going to talk about it in terms of angles. So we have a couple of words we have to define real quick about angles. So the interior of an angle, the set of all points between the sides of an angle. So for example, if I were to draw an angle ABC, okay, then any points that are on the interior, so for example, I'm just going to draw in an X and a Y in here. Those points are interior, okay, because X and Y are between the two sides of the angle. If I draw a random point Z out here, that would be exterior of the angle, all right? So it's the set of points that are outside the angle. Measure of an angle, I think you guys already know a lot about that too because I've already even heard you guys say this, but the measure of an angle is given in degrees. And something you've got to know is that 1 degree is 1/360th of a circle. The reason for that is because a circle has 360 degrees. And I think that's something you guys know also. All right, if you turn in a full circle, you turn 360 degrees. So we've got this angle addition postulate also. So we did segment addition up here. Now we have the angle addition postulate. If S is in the interior of angle PQR, so let's draw what that would look like. So I'm going to draw this angle over here, PQR. Okay, and S is on the interior, so I'm just going to pick a spot. I'm going to say it's right there. Okay, well, I can draw a ray from Q through S then. And now I've just made some angles. So this means that the measure of angle PQS, so this angle, plus the measure of angle SQR, so this angle, has to equal the measure of angle PQR, which is the whole thing. Okay, so again, we're kind of looking at a part plus part equals whole. So this part, and then we've got this part, and together it makes the whole thing. Okay, so we're going to be looking at a lot of different examples over the next couple of days. A couple other things we got to blow through real quick. I think you guys already know these words also, but an acute angle measures greater than 0 degrees and less than 90 degrees. Okay, so it's acute because it's little. A right angle measures exactly 90 degrees. An obtuse angle measures greater than 90 degrees, but less than 180 degrees. A straight angle is formed by two opposite rays. Okay, and it measures 180 degrees. So opposite rays, so I can have a ray pointing this way and a ray pointing the exact opposite direction. And if we look at that, it actually makes a straight line. So if we look at RT and RS, we can actually look at that as a straight angle, and it's 180 degrees. Okay? Down here, these directions are always going to be the same for these types of problems. You need to draw a picture that matches the description, and then use segment or angle addition to write an equation. So B is between A and C. So the first thing I'm going to do is actually just draw AC. And then B has to be between it. So I'm going to pick right there. And I know I'm going to use segment addition because I'm talking about segments right now. And I know that one part is AB, another part is BC, and the whole thing is AC. So again, if we want to look at it with some colors, we've got AB is there. Okay, and then we have BC, which is the green, and then the whole thing is actually the purple. Okay? Then we've got S is on the interior of angle ABC. So first, draw yourself an angle ABC. All right, it doesn't matter which direction your angle opens, but we do want B to be the vertex, so angle ABC. And we want S to be on the interior. So just pick a spot and draw S, and then draw a ray going from B through S. So we're going to be looking at this angle right here. So that's going to be the measure of angle ABS. All right, and then we also have another angle in there right here. So that's our angle SBC. So the green angle is apart, the purple angle is apart, and then the whole thing is equal to the measure of angle ABC. Okay, we're using angle addition here. And notice every time I write an angle, I write this little M in front of it. That means the measure of angle ABS. Whereas if I didn't have that, I would just be talking about angle ABS and I wouldn't be talking about the measurement. Okay? Two more things we got to do real quick. You are actually going to need your protractor. So hopefully you guys all got your protractor with your school supplies. If you didn't, please make sure you go to the bookstore and pick one up. All right, but we are going to measure these angles here. So to measure the angle, we need to put the corner on the vertex. So if it helps, put an actual dot on the vertex of your angle. Okay, and we are going to put the corner right there, and you also want to make sure that this 0, oh man, did that just stop my video? I sure hope not. You also want to make sure that this 0 is actually lined up with one of your rays. Okay, so if I zoom in a little bit, you can see that it's lined up right now. So my vertex is right there, and it's lined up. Here's the 0, so I want to focus on the inside numbers, and I can see that this goes through 55 degrees. So the measure of this angle is 55 degrees. Okay, so because that is less than 90 degrees, I know that that is an acute angle. Okay, then we can do the same thing for question number 4. So I actually want you guys on your own to use your protractor, measure it, and tell me whether it's acute, right, or obtuse. All right. Then question 5 has you draw your own angle that measures 55 degrees. So in order to do this, the first thing we have to do, we can just use our protractor as a straight edge, is we're going to need to draw our initial ray. So I always just kind of draw a line, an array like that, or kind of it's not really a line since it has a start and a stop. We're going to measure 55 degrees. So I'm going to have this be my vertex, which means I'm going to have point E right there as my vertex, because that's the one that's in the middle. So I'm going to line up E and line up my 0. All right, and I want to go 55 degrees. So I'm going to go to, here's 50, here's 60. I want halfway through. There's my 55. And then I'm going to connect E to that dot that I drew. And there's my 55 degree angle. Now I just need to measure it. So it's angle GEO. And there's my 55 degree angle. All right. If you had any questions, please make sure you wrote them down. We will talk about them in class. I will see you guys later. Bye.